Let's start with some type of video just to illustrate what we're going to be talking about during this part of the or during this workshop. With that being said, this next video is roughly about 6 minutes or so. So once again, to talk about data, bases, and SQL. Most of this we've spoken about, but once again, this is just tied all together as far as database and understanding exactly what they are and how SQL is written into the database. So that being said, check this out, and once it's done, we'll keep going.
Welcome to this tutorial series on SQL and database. Welcome to this tutorial series on SQL and database. But before we learn about database, let's understand what is data. In simple words, data can be facts related to any object in consideration. For example, your name, age, height, weight, etc. are some data related to you. A picture, image, file, PDF, etc. can all be considered data. Now, what is a database? We already know what data is, but this data could be random. A database is a systematic collection of data. Since the data in a database is organized, it makes data management easy. What is a database management system? DBMS. Database Management System, or DBMS, is a collection of programs which enables its users to access a database, manipulate data, and help in the representation of data. It also helps control access to the database by various users. Let's discuss a few examples. An online telephone directory would definitely use Database Management System to store data pertaining to people, phone numbers, and other contact details. Your electricity service provider is obviously using a DBMS to manage billing, client-related issues, to handle fault data, etc. Let's consider the Facebook. It needs to store, manipulate, and present data related to members, their friends, member activities, messages, advertisements, and a lot more. We can provide countless numbers of examples for usage of DBMS. Database management systems are not a new concept, and as such had been first implemented in the 1960s. Charles Bachman's Integrated Data Store, or IDS, is said to be the first DBMS in history. With time, database technologies evolved a lot, while usage and expected functionalities of databases have been increased immensely. Types of DBMS. Let's see how the DBMS family evolved with time. The following diagram shows the evolution of DBMS categories. There are 4 major types of DBMS. Let's look into them in detail. Hierarchical. This type of DBMS employs the parent-child relationship of storing data. This type of DBMS is rarely used nowadays. Its structure is like a tree with nodes representing records and branches representing fields. The Windows registry used in Windows XP is an example of a hierarchical database. Configuration settings are stored as tree structures with nodes. Network DBMS. This type of DBMS supports many-to-many relationships. This usually results in complex database structures. RDM server is an example of a database management system that implements the network model. Relational DBMS. This type of DBMS defines database relationships in forms of tables, also known as relations. Unlike the network DBMS, RDBMS does not support many-to-many relationships. Relational DBMS usually have predefined data types that they can support. This is the most popular DBMS in the market. Examples of relational database management systems include MySQL, Oracle, and Microsoft SQL Server. Object-oriented relational DBMS. This type supports storage of new data types. The data to be stored is in the form of objects. The objects to be stored in the database have attributes, for example, gender or age, and methods that define what to do with the data. PostgreSQL is an example of object-oriented relational DBMS. So what is SQL? Structured Query Language, SQL, pronounced as SQL or sometimes as SQL, is actually the standard language for dealing with relational databases. SQL can be effectively used to insert, search, update, and delete database records. That doesn't mean SQL cannot do things beyond that. In fact, it helps in optimizing and maintenance of databases and much more. Relational databases like MySQL, Oracle, MS SQL, Sybase, etc. use SQL. SQL syntaxes used in these databases are almost similar, except the fact that some databases use different syntaxes and even proprietary SQL syntaxes. An example of an SQL statement: select star from members where age is greater than 30. DBMS stands for Database Management System. We have 4 major types of DBMSs called hierarchical, network, relational, and object-oriented. The most widely used DBMS is the relational model that saves data in table formats. It uses SQL as the standard query language. SQL is the standard language used to query a database. The database approach has many advantages when it comes to storing data compared to the traditional flat file-based systems.
Okay. This will all, again, this video, the presentation will be online for those that may have had difficulty hearing it. This workshop is going to be highly interactive. From this point forward, a lot of the things that's going to be done via the workshops or classes together is going to be highly interactive. Where you guys are going to be interacting with myself and also interacting with the database that you created. So this part of the presentation today is going to be me interacting with a lot of the data that we've incorporated, that we've imported into the database. But it's things that you can also do yourself because you have the same data set within your database, because that was the last homework assignment that each of you had. So, why a database? A database management system provides the following. It allows concurrency, control security, maintain data integrity, provides for backup and recovery, which is very important. When you're maintaining data, the data is only as good as its availability. If it's not there, it's no good. So quite often within the database administrators and those who maintain databases, they do constant daily backups of the database. They can always recover if something catastrophic happens to where they lost the data within the database. So backup and recovery is an essential part of a database. Control redundancy, allow for data independence, provide non-procedural query language, and perform automatic query optimization. Now, in all of these, most of these are things that we're either going to see or we're going to do. But what these are some of the reasons as to why a person would choose to use a database. Most companies nowadays use databases in some way, shape, or form, if not all. And the most common, as the video showed, are the relational databases, which we'll get to why relational in a second. What is SQL? Common language for a variety of databases. It's the ANSI standard, American National Standards Institute. So it's a standard when it comes to querying databases. There's two types of SQL, two forms of SQL. One is the data manipulation language. It's the select statement, which is primarily what we're going to do today in the next couple of weeks. Towards the end, we'll do some create. You did create as part of your homework assignment, and I'll show you what you did and how you did to create. But to create is DDL, data definition language. It creates tables and creates other data elements within the database, whereas the select statement is just, it manipulates queries, updates, and does things against data. Pros, very flexible, universal. Once again, some of the other types of databases, again, we're utilizing MySQL, which is a very popular freeware version. Oracle is another popular. Oracle is probably the most popular form of relational databases. Microsoft Access, which comes on most computers, Windows-based computers. SQL Server, which is a Microsoft product. Each of these utilize SQL, and there's some slight variation. Again, the base SQL is the same. Syntax is slightly different. When I talk about syntax, we're going to get into that in a second. There's some slight variations amongst the different database languages, how they code their SQL, but the standard syntax is the same. Again, slight variation, very slight, but it's pretty universal. Cons requires structured database knowledge, which is what this program is about. Understanding that database knowledge, being able to write SQL against the relational databases, the purpose of this class and the purpose of your involvement with this organization and this company moving forward is around databases and the rest around SQL. SQL required element. Within SQL, a SQL statement, there's two statements that's required, the select and the from. The select statement defines what is to be returned, separated by a comma. The asterisk means all columns from all tables in the select statement. The from defines the table of views selected, used by the select or where statement. You must have a from statement. Multiple tables, views are separated by comma. So this is the basis for all select statements. With that being said, once again, I said it's highly interactive, so we're going to start getting interactive here. So once again, this is talking about the basis of a select statement. The select and the from. So going to our tool, most of you guys uploaded your data, and it looks similar to what you see here. I have access to everyone's database. You guys have access to yours and the iThinkInfo one. I put iThinkInfo out there so you guys can have an example of what it should look like once it's imported. So once again, each of you have gone through the exercise of importing your data. So when you connect to Toad, we're all working from the same data set. We have individual databases, but the data contained within our database and our tables is the same because we imported it from the same data set. You guys understand that? Again, that's important to grasp. When you imported the Excel files, even though you did it separately, you all had the same file for the same data set, the same data source, and you created tables with the same naming convention. So that being said, any SQL or select statements that I write myself as part of this class, you guys can write the exact same select statement and then it render the exact same results because we created the exact same database environment. Everything's the same. The table names are the same, and the data contained within is the same. So I'm going to work from the iThinkInfo database, which is the one that I populated. So in order to create a new window by which to write the select statement, File, New, and Editor. It provides you with another window, another tab here from which you can edit. You can close this and make this one. So these are other windows. This is the intro window. You can close this one. This is the window that pops up when you hit a table giving you a view of the contents in the column. So we can actually close this one. And this is the one we just opened, which is the editor window. So we open up a new editor. It's by default is titled Untitled 01. If I open a new one, it'll just give me 02. So now I have two windows that I can write separate select statements in. So the first window, once again, the very basic element of a select statement is select and from. So you start with the select statement. It's the basic select. S-E-L-E-C-T. If you hit space, once you're connected to the database, the good thing about using tools is dynamic. So as you start typing, it helps you fill in the next part of your select statement. So again, select is the first part of it. If you hit space, it's going to bring up the tables by which you can select from. So the tables that's contained within the iThinkInfo database, or in your case, it's going to be a training database, but it's going to bring up the tables within that database. So we're going to start off looking at the user activity, looking at the, let's look at the day table. Okay. So once again, this is very dynamic. So when I selected the table from which I want to pull from, it started giving me the fields that I can select from that table. That's the dynamic nature of Toad. Let me do that without that so you can actually see. So if I didn't use, it's still going to give me this. So I'm not going to select the table. I'm going to type it in. Let's look at the day table. This is too dynamic. Okay. So it's going to say from, this you can pick the field. Once again, the asterisk, the star, brings back everything. Select everything, hit enter. Again, this is very dynamic, so it's creating the SQL statement for you, as opposed to you typing it yourself, which I don't like that often. So I'm going to go select star from table. And then you close the select statement with semicolon. You highlight it, and this is the execute. This or F5, I use F5. It executes the statement, and bring you back the results. So what I just did was I select asterisk, which is everything, going back to our presentation. The select statement, select defines what is to be returned separated by a comma. Asterisk means select all columns from all tables in the select statement. In this example, we select everything from the domain activity table. So it renders all records from this table with no restrictions. Again, this is the most basic select statement that you can write. But it has to be a select and it has to be a from. If we do not use the asterisk, again, we can select the fields that you want to bring back. So say you're only interested in looking at the name of the domain, the day of the week, the date, and the number of page views, the enter. So now we have select the field called domain, the field called day of the week name, the field called date, and page views. And if you execute this statement, once again, it brings back every record, but only brings back the columns that we specifically told it to bring back. The domain name, day of the week name, date, and page views. So back here, defines what is to be returned separated by a comma. We define what fields we want to look at and separated them by the comma. Now if you notice, there's a hyphen these columns here, you have this character here because there's a space in the field name. In this instance, it did this because date is a system, a common field within the system itself. So it put the special character here to identify this as not being the system common date field, but the field from the database itself. So once again, you only see special characters if there's a space in the actual name or this. Now, and I can show how this differs because we can alter the name of this field. And it will show you how the field name won't contain the special character. So let's go here for a second. Let's actually close the table out. I'm not going to save it. And onto this table. And I think Tammy needed to go and change some characteristics about the table after she imported the data. And this is how you do it. You highlight the table that you're looking to change something about. Right-click and go to Alter. Once you get here, you can alter the name of the table here. So if you're typing and you misspelled it, you can go here and change the name of the table here. And also, under the column section, you can change the name of the field. And actually, I want to look at the day table. Alter this one. So column, again, day of the week, again, has the spaces. If I took the space out and put an underscore, for example, and I'm just showing you guys this is an FYI. Okay, so now the day table, the column doesn't have spaces here. So with my select statement, everything I wanted. Let's get specific here and bring back the one field that we altered. Because again, I want to show you how. You see, there's no special characters here. So once again, you only would need that in your SQL syntax when there's a space in the name of the field within the table. So again, this is the most basic select statement you can write. Select star or select the specific column from a specific table. Any questions about that? No question? Not a one. This is crystal clear to everybody.
Well, Robert, why did you say there are a special character around date?
Because it's a field that Toll uses. It's like a very common field. So within the SQL syntax, you can use date to render what today's date is by simply using date. So it's a field within the SQL syntax that is a system used field. So what this does, you put the special character to identify this as a non-system specific field. Even though if I took it off, it'll still give you that. You still get your results. But just from a code standpoint, it's better to put them in. That way, you're not confused, or anyone in the future is not confused when they're looking at your code. They see that it's meant to be a field that's specific to this table, as opposed to being meant as a system utilized field. Like for instance, if I did, I'm going to show you an example of a system utilized field. If I did now, this is going to render me the time right now. So this now is a system utilized word. Date is also one of those system utilized words, but it's used a different way. And we'll get to how it's used later. But that's why they put the special character right there. But again, that's the very basic select statement, the most basic select statement that you can get. Even more basic than putting the column and putting a star. Because you're returning everything from a table. Moving on. The where statement. It's optional because it's not required to execute a SQL statement, but it's not optional really, because this is where a lot of the analysis takes place when you start to really utilize the power of the where statement to analyze data. Where statement is optional. It defines what records are to be included in the query. It uses conditional operators. Equal to, greater than, less than, greater than, equal to, less than, equal to, not equal to, and not equal to. Both are not equal exclamation equal is not equal to, and the less than, greater than, without the bracket. This is just in here to separate these two, but it's the same. It does the same thing. Between is an operator between something and something. In is a list. Like is a wild card. Use the parentheses as the wild card symbol, and then what you're looking for after. We'll get to examples of these in a second. Is null, not, multiple conditions linked with and or, strings contained within single quotes. Let's get to some examples of these various things. So, you got select from, again, the very most basic element of a SQL statement. The next part is the where. Okay. Once again, the tool is very dynamic, and that is going to bring up, it knows what fields to bring you because it knows what table you're looking at. Because you created the select star from and named the table you're looking to pull fields from, so it knows exactly what field to bring back to help you create your condition. We're going to look at, in this example, look at a day. Okay. Once again, these are the operators that you can use within your where statement. In this case, we're going to look at equal. So we want to look at where day of the week name, actually, let me change this back. I don't want to confuse you guys. I want to alter this back, but I don't want my table name to be different than yours because it's important. I'm writing a SQL statement that it's the same. I'll change this back. Okay. Let's get back. Once again, where day of the week name is equal to, and let's say we're only interested in looking at, and once again, this tool is really dynamic. So what it just did is it looked at the table that I'm interested in. It looked at the field that I want to place a condition on, and it brought me back the available values, the distinct values of every record in that table. So it analyzed the table and said, okay, I know you want to create a where condition against the day of the week name field. What field name are you interested in? I want to look at Monday and Thursday. Now, you would think that this would work, but it's not. Let's look at one first, and we'll get back to that point in 1 second. Okay. You want to only look at records where the day of the week name is equal to Monday. So what that does is it brings back only the records where this field, this column, has this field populated with Monday. So this is an example of one operator being applied with the where clause to restrict the data set that we bring back with our select state. We can further restrict this, as it says you can have multiple conditions linked with and or. So going back to what I just tried a second ago, we can further make it by saying and the same field is equal to, and once again it's very dynamic, a Thursday. I didn't get any results back. Any idea why? No. We're going to explain that in a second too. If I change this to OR, it brought back records where the day of the week name was Monday or Tuesday. We put the and in here. What this select statement does is it looks for records where the day of the week name is Monday and it's Tuesday. So it's looking for a single record whose day of the week name is Monday and Tuesday. That's not possible because there's only one field or one day of the week name in a field. What we could have done here, and with the AND operator, you can have a list. So here, what we could have done, we could have put where day of the week name is in, and then you have your list here, and you can list, separated by a comma, the days of the week that you're interested in. So this is saying for a given field, select the record if the day of the week name is in this list. So that being said, it brings back every record with the day of the week being Monday or Thursday, because once again we use the and operator. So we've used the equal operator, we've used the and operator for a list. Let's look at the not equal operator. The not equal operator, again, we're going to look at a single record. This brings back every record that's not equal to Monday. So it returns every record where a day of the week is not equal to Monday. This like operator is one of my favorites. It's pretty commonly used as well. With the like operator, say you didn't know exactly what the name, or say you want to search for a certain character or a certain string within a field. So use the like, and say we knew our day of the week contained some characters, not we didn't know all the characters. If you use the wild card, what it does is it looks for anything within that field that ends with IDAY, but anything before that can be anything. It's a special character. The only field that has this condition is Friday. Once again, this wild card is another operator that can be used. So we've looked at the select from, again, which is the most basic statement, but then we added a condition to it with the where clause. Any questions about the select, from, and the where clause? As you start to write, please. The question? Okay. Let's proceed. Let's go back to Thursday.
I have a question.
Okay.
So
please.
is there, after that character, is there I can't really make out. Is there a space like?
Yes, there is. There is.
Okay, so there is a space. Okay.
Yep, there's a space, and the space is what what Enact's told to bring up the options. Yeah, so see, select space. It gives you the tables you can select from. And it gives you the fields in which you can look at.
Okay.
So now we have select and the fields, everything. Then you can add the where clause to be specific, and it even brings you up the fields that you can look at. And let's look at date. With a date equal to, it gives you, once again, the dates that's available in the table right now. So let's look at the first another operator between. Look at that. It's something, this happened with the date field. Okay, select specific columns from the domain hour activity table with hours 15. Hours 15, this is military time, it's 3 o'clock. So it looked at all the records where the hour equal to 15 and brought back the 14 corresponding records. Specific fields that we said to bring back, or it brings back everything that we put the asterisk key in the data set. Brings back everything for the records that we specifically told to bring back, once again, hours. That's the where statement. And an or statement. Multiple where conditions are linked by and or statement. And means all conditions are true for the record, or means at least one record of, well, at least one of the conditions are true. You may group statements with the brackets. Be careful mixing and or statement. As you can imagine, if you begin doing a lot of and or, it can get quite complicated. Some of the select statements that you write can get complicated, and it will get complicated. So let's look at a few of them here. So I'm going to look at this data set because it's too small. Let's change to a different table. Let's look at the activity table. Okay, so this brings back the domain, source, user type, day of the week name, hours, date, page used, username, available fields. Let's bring back everything and start off our where statement. So let's look at the word day of the week now. Let's look at the user type. Let's say we only want to look for new users. Is it a new visitor? One of our options is new visitor and returning visitor of the existing records in the table. So if there are more records with different options, they'll appear here as well. Let's only look at the new users. So we have 307 records of the, and I can do this, I can still execute this statement without including the word clause by highlighting just that part of it. So it'll bring back everything. There's 372 total records. So with the where condition applied, there's 307. Now, let's get back to where we were saying how we can use the and or statements to make this even more complex. Let's use the and statement. And let's do a page views is greater than 25. So we're only interested in records where the user type is new and where the number of page views is greater than 25. It's one record. Let's decrease this some so we can get more status with that. Okay. So of 307, we have 3 records where there were more, at least there were more than 10 page views. Down because I want to have a dark back there. Okay, so now we're down to 20 records that meets this condition. New visitor, where the user type is new visitor, and the page views is greater than 2. The other operator we can use is greater than equal to 2. Let's see if there's a record in here that's equal to 2 and greater. Right now it's 20 records, but if you ran this statement, you get 56. And that's because there's some record sets where there's exactly 2. If you put the greater than sign, it's only looking for 3 or more, which is 20. But if you put the greater than equal to operator, it returns 56. So now we have the condition where we're looking for new visitors, new users, new visitors, and the page views of 2 or more. The or, and you make group statements by putting them in brackets. So let's do this. I want to look at users who are new visitors and page views is greater than equal to 2. That's my one condition. I'm using an or statement. Or, let's see. Or page views is greater than equal to 2. I should get back every record, or just about, because what we did is we looked at this first condition, and we want new visitors with page views that's greater than equal to 2 as one condition by itself. It can meet this one condition by itself, or it can have less than or equal to 2 page views. So this statement has 2 conditions, but within one condition, it has 2 conditions. So it's 3 conditions total. But these, because we enclose them in brackets, are considered one condition. And this is an example of how you can further enhance your select statement to make it even more specific. So, okay. Change this. Let's do where it's a new visitor, where the type is new visitor, or the page views is greater than equal to 319. So in this instance, it looks for either or condition. Here, both conditions had to be true, and it brought back 20 records. And this one, either or condition has to be true. It's going to render 319 records. So your slight syntax difference makes a huge difference in the resulting data set. If you put an or here, yeah, it's going to bring back more record sets. This is the and or statement. Order by statement defines how records are to be sorted. Must be in the select statement to be ordered by. The default is ascending, and you can sort in a reverse descending order. So let's go here. Okay, once again, we have our select statement. We're selecting all the fields from the domain user activity table where the user type is new, visitor, and the page views is greater than equal to 10. 20 records. The order by once again, it brings up the available options. Order by is you want to order the result set that you have by one of the fields. In this case, we're going to order by page views. And if you do nothing, the default is ascending order. And you can type ascending, which is ASC, and it'll give you the same, but the default is ascending. But if you put descending, it'll give you the opposite. So this select statement, you select everything from the main user activity table where the user type is new visitor, page views, and the page views is greater than equal to 3, but then we order the page views result in descending order for the returning records. So the 20 records that we brought back, we ordered them by page views in descending order. You can order by any field. So let's order by the source. And this is going to order the source column for us. We'll order the source column again in descending order. What you can also do is have two fields. So say you want to do source and page views. It gives you the source, but then the page views in descending order. So for this group, for this source, all the records for that source, the page views are in descending order. And if you go in ascending order, same thing, it's going to reverse that. So for the same source that's sorted and grouped, it sorts the page views in ascending order. So that's the and or statement and the order by statement as well. Any questions about the and or the order by statement in our example here? I know I got a question or two. That's that crystal clear? Tammy, Carrie, Yvonne, y'all got it?
I got it.
That's great if y'all do. I mean, I'm excited about that. Because, but again, this is the basic select statement, as basic as you can get. Well, this is not as basic as you can get. This is, but then we add the ref condition, and then we ordered our result set, grouping by source, then by page views in ascending order. Okay. Group by statements. Perform common mathematical operators on a group of records. Must define what constitutes a group by using a group by statement. All non-group elements in the select statement must be in a group by clause. Okay. Group by. All right. Let's select some specific fields here. Let's say, let's look at domain, source, and page views. So these are the fields that we're concerned about from this table. New users, page views, greater than equal to 3. Okay, our results. Now say what we want to do here is, okay, we know they're new users. We want to sum up page views. We know they're new users, so let's keep it here. So we use the sum, and these are different functions that you can use. So sum is a function. So you're going to sum up page views. Average is another common one that we can use. Of course, it's a mathematical operation, so it has to go against a numeric field. So in this case, we're going to sum up page views. But in the statement said, you must define what constitutes group by using a group by statement. All non-group elements in the select statement must be in the group by clause. So everything that's not being calculated, that's within your select statement, must be in the group by clause. So we're going to group by everything that's up here, that's in our select statement, that's not being calculated. Okay, so now we have 15 records. So what it did is it averaged, summed up for each site, regardless of what day the activity happened on, the number of page views that happened on that day. Say we don't care about the source. We just care about how many page views we don't care about source. Just the number of page views. So it took out the source field, but summed up the number of page views for the new user by the day of the week. So with the group statement, you perform some type of mathematical operation, which in this case we use the sum mathematical operation, and you group by all non-group elements in the select statement. So the non-group elements, the only element that's grouped here is page views, only calculation. Everything else in your select statement has to be contained within the group by clause. And then we can go back to where we had it before, order by the calculation. So we group by, but the resulting data set went even further and ordered the sum of page views in descending order. Ascending order. All around. So the grouping in SQL, we use the group by clause to group the fields. Group by. We put some conditions within the where clause, and we ordered. Once again, if you made this condition slightly different, notice how your numbers are going to change. Because the where clause is new user or as opposed to new user and. Any questions? No questions?
I don't have any.
Would that carry?
Yeah, it was me.
Okay. Javon, any questions, Javon? Okay, we're going to proceed. Now, this next piece I'm going to show you is we're going to join more than one table together. When you look at a database, again, databases have its fields. So in this table, we have these fields. In this table, we have these fields. The relation between databases, the power comes when you can connect more than one table together. So relationally, they're able to be connected. In order for one or more tables to be connected, there has to be a common field between the tables. In this data set, with these tables, the common link between each table is the domain field. You have domain in each table by which you can link the various tables together. There's other fields that can also be utilized to link tables together. So we know that one common link is domain. Another common link is source/medium. Day of the week is another. So let's take a look. Let's take an example here. Let's look at let's start with the user activity table. A certain day. So we bring back everything from this table. And the linkage of more than one table together, you use a comma to separate them. And once again, code is dynamically codes. You put the comma and you space. It brings up the other tables that you could link together. So we're going to look at the user activity table and also look at the landing table. Now, this by itself brings you back more, because what it's doing is it's joining every record within the table user activity to every record and landing activity. And it's going to give you some outlandish number, like thousands, maybe millions of records, which is not right. But you got to link it together by the common field that we spoke of before. Okay, once again, this does a dynamic for you. Well, one table common field is equal to the other table's common field. And we mentioned that the domain is a common field between each table. So you want the result set to link these two tables together by domain. And this is where we're going to use our AND statement. Not only are we going to link where the records domain are the same, we also want to look at records where the date is the same. And we mentioned earlier, the source. So we have 281 records where all those conditions were the same. So what it's saying that on this day, this brings back, when you put the asterisk in, once again, it's everything. It brings back every field from the first table, and then brings back every field from the second table. But what we've done here is for this day, from the activity table, we see new user Friday, the hour was 13, there were 55 page views, but also from the landing activity table, we saw that on this day, this landing page received 65 page views. So we connected more than one table together, each table containing different bits of information, but we specified what conditions to join the table on. Only if the domain is the same in both tables, the date is the same in both tables, and the source is the same in both tables. Do you join them? If they don't have that common connection or those common linkages, don't join the table together. That's how you join more than one table together. Let me see here. I'm going to connect to I connect to my production database. I've got mounds of data. I'm going to give an example. Okay. Okay, let's look at this. We have two tables here. Chicago business owners. So these are business owners within the Chicagoland area. The account number there for the city, the legal name, first name, last name, middle name. And this table here is the businesses within the Chicagoland area. License ID, name of the business, address, zip code. These are other characteristics or other fields about the business. Type of license that they've got. Again, just different, lat long, just specific information about a specific business. So we have two tables here, one that has the business owner, another that has the name of the businesses. There has to be a way to link the business owner to his or her businesses. Here, the account number for the business owner and the business owner's legal name. In the business table, what we have here is an ID specific to the business license ID, but once again, that account number. This account number refers to the account number of the business owner. So that's the linkage between these two tables. This table lists the businesses owned by a business owner and the license ID for the business, where this table has the actual owner and his or her legal information. So let's open a new editor. And what we're going to do is connect the two tables together. Because alone they're relevant, this table contains the business owners and their information, and this table contains the businesses and its information. But this table alone doesn't tell you who the business owner is. It just tells you which businesses there are. This table right here just tells you the business owners. It doesn't tell you which businesses the owner has. So within the SQL, and the power of SQL is you link those two tables together by the common field of account number. So we start putting together our select statement. You want to select business table, select star from the two tables. Once again, is the businesses and the business owners and the business. And your where statement, you want to connect them where the account number in the business owner table is same as the account number in the business table. And when you run this, that happens in MySQL sometimes. Again, these tables are pretty large. The resulting data set would have been large, so it errors out. So let's look at a specific business owner and say, well, the account number. So the account number, I thought I saw one equal to 2. No, I didn't. Let me see. Okay. It's still probably too big. Yeah, it's too big. This table's too large. A lot of business information. Let's do this one. Schools. This is the schools in Chicago and the report card for each school. So this, once again, we have each school in the Chicagoland area, school name, details about the school, and a report card. A report card is information about the school, how the school did in math and reading, growth for math and reading year over year, performance, how the school performed overall, and other messages about the school, family involvement. So what you could do with this data set is you could look for very specific information about a school. So if you wanted to know which schools were graded certain ways, you could use the where statement to look at specific fields. So where the overall foundation is equal to organized or not yet organized. And the power of a database is you could run reports to see, based off this data, which schools fall in certain groupings. So we had schools, school detail, particular school. Any specific school you guys interested in? Chicagoland people? No? All right, Tammy. Let's see. Whitney. Okay, and Whitney Young. It's elementary school. That's the high school. It's a Whitney Young Elementary School? I don't know that one. I know Tim, but I don't know why I did that. Let me see. There we go. Whitney Young High School. Okay. So, Whitney Young High School, there we go. And the details, let's say, and connected to the report card for Whitney Young High School. Mr. Thomas, school ID. Now, see, this one is different. You see how this is school ID underscore field name, and here it's without underscore field name. That's very important because that's a different field name. The same field is school ID, but the field name is spelled differently. One is school without the ID, without the underscore, and the other has the underscore. And that's why the system didn't pick up that common connection between the two automatically because it's not the same. So one for the school details table, it's school ID, but for the school report card table, it's school ID. That's bad database design. All right. I don't know what in the world you do. Troubleshooting with you guys here. I don't know what in the world. Oh, that's not right. Okay, this school ID isn't the same. Let's see. I don't know what it was. Okay, let me work on that. But you guys get and understand the basics of a select statement. Any questions about this?
No.
About writing a select statement, writing the where clause, grouping by, and order by. Any questions about that there? Okay. Now, the homework assignment for this week is going to be writing your select statement with where clauses and grouping by against the tables that you import into your database. So sometime tomorrow morning, I'll be sending out the homework assignment, and it's going to ask for you to render a said result. So say, tell me the number of page views there were on this day. You'll have to write the select statement to return the number of page views there were on a given day, or the number of the records where the page views on a day was more than 3. So you'll have to write the select statement, but then you'll have to put together specific conditions to render the expected result set. And you'll have to provide me with the SQL statement. So I'll give you again, it'll probably be a PDF or a Word document. You can log into your database environment and write the SQL directly against your tables. And then copy the select statement, paste it into the document, and that can be your handout back to me. Any questions about the homework? You haven't gotten it yet, but the premise behind the homework, again, I'll give you a scenario and ask you to write the select statement to render the expected result set. And you'll have to write it. The first one may say, select all records from the user activity table. And you guys can put together a select statement. Once it runs appropriately, just copy the statement and paste it into a document, the Word document I give to you, and send me the select statement. And that's it. Any questions?
No.
Okay. No questions. You guys have a wonderful week. Get the homework assignments out to you. If you have any questions while writing your select statements with the where clauses, feel free to reach out to me via any medium, text me, call me, email me. I'm available. But again, you guys have a wonderful evening.
You too.
Bye.